Let's look at the most often asked questions in the interview in Python with characters, strings, and numbers. The first question, probably which is very famous, is to give a list of names over here and ask if a given name is present in this list. So we have a list of names: Frederick, Hashim, Ravi, Roshni, and John. So given a name, we want to check if that name is in the list. So this is a very popular question. So let's say that we give a name and it says you're welcome. If the name is in the list, it says you're welcome. If the name is not in the list, it says see you next time. So the way it works is there is a list of strings, there is a list of names given here, and then the input statement takes a particular string, a particular name as input, and obviously any input that goes into the input statement, it returns a string. So what you get out of the input statement is already a string, and then here with the in keyword, which is a membership operator, so with this in keyword along with the if statement, and your name is the name that you give through the input statement, and your name is being checked in the names, and then it says you are welcome. So let's do this again. Let's clear the output and let's give a name, and it says you're welcome. So let's give another name, Robert, and it says see you next time. So here we are just using the if loop and the membership operator in to check if the given name is part of the list of names, which is the names list. So we have already given a list of names, and then the input is taken through the input statement, and then if statement is used to check this. So this is a very simple but powerful program to check if the given string is part of a list already. And Python is very good in doing this quickly. The other thing that is very often asked in the interviews is how many unique characters are present in the given string. So how many unique characters are present? So we give a sentence, and then unique characters, we have a dictionary, we take a dictionary, and then whenever there is a character that comes, we mark the value as true. So this is an empty dictionary. Unichar is an empty dictionary. So when a new character is seen through this for statement, this new string is where the string is given, and then ch looks for character, each character in the string, and then this character acts as the key of this dictionary. So for that key, the value is true, so it has occurred once. Suppose if a character occurs twice or thrice, it's again overwritten as true, so it doesn't change the fact that it has occurred. So even if a character has occurred 3 times, the true boolean is overwritten, so therefore it is considered as one character. Finally, we find the length of the unique character, how many pairs, how many key values are there in the string. We find that out and then print it, and that many unique characters are present in the given string. So let's give a string, hi, how are you doing? So you can say the I is occurring twice, but still, so it says the string contains 13 unique characters. So but if you see that the I is counted only once, so we can actually look for the unique characters only once. So the space also has occurred many times, but it's still counted as only one. So the number of unique characters that are occurring is 13. So this is a very simple way of finding the unique characters in the given string. The next interesting program that's very often asked in the interview with respect to counting of vowels and the frequency of vowels in the given string. So here we take vowels both in capital letters and small letters, because we want to be sure irrespective of the case, we are able to find the the vowels. Right, here we go. So we have the dictionary which is taken as V and the count is 0. Let's look at hi, how. So you can see the number of vowels. So I has occurred once and O has occurred once, and even if I give it in caps, yeah, it's able to say I has occurred once and O has occurred once. So you can also convert this into lowercase letters, and then it will give you the I has occurred one time and O has occurred one time. And this will also count if the vowel has occurred more than once. So let's check for the occurrence in hi, how are you doing? So you can see that if there is more than one occurrence of the word, then it's able to count the I has 2. In case we are able to give a mix of both the capital and the small letters, you can see this this I is in caps and this I is in lowercase letters, but you can see that it has considered everything as a lowercase letter, and it has said I is 2, right? And you are able to see that. In case we don't have this lower here, in case we are giving a mix of both uppercase and lowercase letters, so you will see that capital I has occurred once and small I has occurred once, which is not a good way of displaying, because it should have combined both these I's and shown us as 2. So which is why we convert this into lowercase. So that we are able to consider everything as lowercase letters. So so in that case we don't need the caps also here, because everything is converted to lower. So even if you remove the caps vowels from the vowel string, so it still works, because the caps is removed from the vowel string. Because we convert the input into lowercase letters, we are able to find that the number of vowels in lowercase is 2. So to see how it works, you can see that whenever there is a space, we say continue. We don't count the space in the string. So this is important, because whenever a space occurs, we don't want to consider that in characters. We just want to go to the next one. And if the given string is if the given character is in vowels, which is A, I, O, U, the number is incremented. All right, the number of counts of the vowels is incremented, and also the V is the dictionary which keeps a tab on the frequency of vowels that is present in V. So CH, which is a character, acts as the key in the dictionary, and if it occurs more than once, the count is incremented. If it is occurring for the first time, the count is set to 1. So this if statement is for repeated occurrence of a vowel, whereas this else statement is for single occurrence, the first time occurrence of the vowel or the single occurrence of the vowel. And this if statement is for counting the total number of vowels. So this is interesting in the sense that we also count the number of vowels, as well as we count the frequency of the vowel. So let's say this program is very interesting. So it gives us the count of the vowels. So this is a most popular question that is asked invariably in many of the fresher interviews, and many of the projects which have this kind of code, you will see this occurring again and again. So make a note of this. This will go a long way in helping you ramping your knowledge of Python. The next question, which is related to string, is to find out how many times the frequency of each character. Okay, you want to count the frequency of each and every character in the string. So this is interesting because it is basically about counting the frequency of characters. So let's say that we have entered a string, so which is the famous panogram. The quick brown fox jumps over the lazy dog. So we copy this string, and if we give the string, it gives us this one is just printing all the alphabets in the order in which they appear in the sentence, but whereas the second one we sort based on the key value, and then we print the frequency of each character. So as you can see, all the characters have come in this sentence at least once, which is good because all the characters are present at least once. So let's look at this interesting program where it counts the frequency of each character in the given string. So the string that we are giving is the quick brown fox jumps over the lazy dog. So here the for loop C goes through each character in the given string, and then if the character is empty, so we say continue. If it is present in the dictionary, this if statement counts increments the count for the particular alphabet present in the dictionary, whereas the else statement puts it into the first time. If the character occurs, then we just set it to 1. But if it is occurring repeatedly, then we increment the count. So here we count the frequency of each character that appears in the string, and the dictionary is a wonderful tool to do this very clearly. And if there is a space, we don't count that because we don't consider space to be a part of the 26 alphabet. So we just skip that. So this is a simple but powerful program which counts the frequency of each character. I hope this makes a lot of sense. Now the next one is interesting as well, which finds out the frequency of each word that appears in the string. Now this is a string where you want to find the frequency of each word. So let's run this, and you will see that the word "the" has occurred 4 times in this sentence. Next has occurred 1 time, 25 has occurred 1 time. So each word, the frequency of each word in the sentence is printed. So how do you do that? We use the for statement, and S is your string. You see, your string is the string that we are giving here, and then we convert the string into lowercase through this dot lower function, which is a built-in function for the string, and then we split the string based on the space character. So once you see a space, we split it, right? We split that, and then we put it into the your string variable. So the your string contains this string, and it is split whenever there is a space. So if you print your string, you can see what is interesting is it's a list of strings, and each one is considered as a string. Whenever there is a space, it is split at space. You may ask, how are you sure that it is splitting at space? Because the default for split is a space. So you could have actually given like this, which would still produce the same output, because here you are explicitly telling that space is the splitting criteria. But even if you don't give anything, it considers default space as the splitting criteria. So here for S in your string actually goes through each of the word in your string. If S is already in the dictionary DC, then we update the count. If it is the first time the word is occurring, then we set the count to 1. Initially DC is an empty dictionary, and when it is the first time a word is coming, then we just update it to 1. Later we increment the count, which is dc of s equal to dc of s plus 1, and this for loop goes through each word in the string. So there is a your string which contains the sentence, and there will be an empty dictionary to start with. And then you go through each and every word in the string, and if the string is already present in the dictionary, we update the count, else we create a new key and set the count to 1. So here we don't use that flag, I just removed it. So you can see very clearly how we count the frequency of each word given in the sentence. So this is also an important program that is asked in the interviews, how to count the frequency of the words that are appearing in the sentence. The other thing that is very interesting is find if the given string is a panogram. So there are a lot. So basically you want to find out that if all the characters are appearing, right? If all the characters are appearing in the string. So you have these alphabets, all the 26 alphabets that is present in a string. What you do is take a character in the string, and if it is already present in this 26 alphabets, then you say continue, then you are fine. If a particular character is not part of this 26 alphabets, right? If you don't find that, right, then you say that it's not a panogram. So if the character is in the string already, then we say that if it is not in the string, then certainly that is not part of the, and we also convert it into lowercase. So as you can see, we intelligently check that take each and every character in alphabets. So there are 26 alphabets here. Take each alphabet here and then check if it is part of this string, right? We check if it is part of this string. If so, the way we are doing it is we take each character in this set of alphabets. We take each character over here and then we check if it is present in this string. Right? Once it is present, then you consider that it is a panogram if each character is present. If it is not present, then the flag is set to 1 and we break out of the for loop. So, and then if the flag was 0 to start with, and then if the flag remains 0 after going through all the alphabets, all the 26 alphabets, and checking for the presence of alphabets in this given string, if the flag still remains 0, what it means is it has considered all the alphabets of this alphabet string and then it is present in the given string, and therefore the flag has not been set to 1 and the flag remains 0. We say that it's a panogram. So this is an interesting program to check if all the alphabets are present in the given string. So this is also the other question. We say that the string, the quick brown fox jumps over the lazy dog. So for example, if I replace this paragraph with the sentence, the quick brown fox jumps over the lazy dog. So if I replace this sentence, it will still say that it's a panogram. So because this sentence is the very famous one that tells us that it's a panogram. So you will find all the 26 alphabets that we have listed here in the alphabet string to be part of this sentence, the quick brown fox jumps over the lazy dog. So hope you are able to wrap your head around this program. So this is one of the most often used programs, most often asked programs in the interviews that find if the given string is a panogram. The other program that has become famous of late is reverse the words in the given sentence, just the order of the words. The last word should appear first, the second last word should appear second from the first, and so on. Right, so let's say that we are giving a sentence. This Python session is pretty interesting. You know what it has done is interesting, pretty is session Python this. So it has printed the words in the reverse order, right? There is a sentence that we have given and it has just reverse printed the words. The order of the words are changed, the last one being the first and the second last one being second from the first, and so on. So how did this do it? So you can see that we give a sentence over here, and then we remove the leading and the trailing blanks from the sentence. The leading and the trailing blanks are removed by using the strip, and then we split the sentence whenever there is a space, and then we get a list of strings. We get a list of strings as the output of this input statement. We get a list of strings, right? Because we have a list here. So that is converted into a list. Once it's converted into a list, this reversed actually reverses the words in the list. This reverses the words in the list, right? So reverses the words in the list. Once it is reversed, we get a list with all the words reversed, but it's still a list. It's not a string. Yeah. So this input statement gives us a string, and then this list converts it into a list of strings, and then reversed will reverse the words in the list, and then we are using the join statement. So there is a space, and each word is picked up from the list. Each string is picked up from the list and joined with this empty space, right? It will not add space for the first word. It will just pick the first word and put it. Starting from the first word, when it adds the second word, it will join with this empty string. So there is a first word, and then there is an empty string and another word, and then there is a empty single space over here, and then another string, and so on. So therefore we get the output interesting, pretty is session Python this. So here the function of the strip is to remove the trailing and the leading blanks. The function of the split is to split the string whenever there is a space. And the input statement takes the whole sentence. This Python session is pretty interesting. Right. Just to debug this program a little more. So if we were to print only up to this, for example, if we were to print only up to this, and then we run this to take the sentence, this Python session is pretty interesting. So this actually just prints the string as it is. So what we are doing is we are converting this string into a list of strings, and then we are reversing the order of the words in that list and then joining with a empty space. So that's what we are doing. So this one-liner is a very powerful one-liner to reverse the order of the words in the given sentence. This is also very handy and also very concise, which makes use of each and every which makes use of interesting features in Python to bring out this reversing the words in the sentence. Let us look at the program to check if the given number is a palindrome. So we take the input, the number is taken as the input here, but the input statement takes the number as a string. So this is very convenient because you can use the slice notation and then use the last number here, which you put as -1, so that the sequence is considered as a reverse. It's a very Pythonic way to reverse the given number. You can see that the number 567 is then is first reversed, and then if the number is equal to the reversed number, then the given number is a palindrome. The num ::1 is a very convenient Pythonic way to reverse the given number, which is taken in the form of a string. So you can see this is the statement that takes the input, which is a number, and then this number is taken as a string, which is very important because only when it is a string you can use this num ::1 to reverse it. And then if the given number is equal to the reversed number, this is where we check for the equality, that the given number is equal to the reversed number, then it's a palindrome. If it is not, then it is not a palindrome. For example, I give this number 4554, which is obviously a palindrome, so which says the given number is a palindrome. Now by the same logic we can also check if the two strings that we give are anagrams of each other, and we all know that the string listen and then the string silent, they are anagrams of each other. The listen and silent are anagrams of each other. One of the easiest way to check if the two given strings are anagrams of each other is to see, just sort the two strings. So if you sort the two strings, they will be in the same order, and also it'll be the same, they'll be in the same order because both of them contain the same characters. When you sort this and when you sort this, the alphabets will be in the same order only if these two contain the same characters. So the sorting the first string and sorting the second string and then checking if those two are equal will prove that the given two strings are anagrams of each other. So in this case, listen and silent are certainly anagrams of each other, and that's what the output will be. If I change a simple alphabet here, it's going to say they are not anagrams of each other. So this is a very simple way of checking if the two strings are anagrams of each other, just by sorting the two strings and then equating them. If they are equal, then they are anagrams. If they are not equal, they are not anagrams. So this is also a very popular question which is often asked of the newcomers or even some seniors to check their understanding of Python and to check if they are able to write Pythonic code. Now the other popular question that is often asked is generate the Collat's conjecture from any given number. As you can see, the Collat's conjecture is if the given number is divided by 2, right? If it is an even number, it's divided by 2. If it's an odd number, the number is multiplied by 3 and 1 is added to it. Let's show this by an example. Let's say I'm giving the number 34. So 34 is an even number, so we just divide it by 2. 17 is an odd number, we multiply it by 3 and add 1. 52 is an even number, so it is 26. 26 is an even number, divided by 2 is 13. 13 is an odd number, 13 into 3, 39 plus 1, 40. 40 is even, so 40 divided by 2, 20. 20 is even, so 10. 10 is even. 5 is odd, so multiplied by 3 plus 1, 16. 8, 4, 2, 1. As you can see, finally the number ends in 1. So the Collat's conjecture is whatever number you give as an input, if it is an even number, it's divided by 2, and if it's an odd number, it's multiplied by 3 and 1 is added to it. So this process continues until it finally ends in 1. So whatever number we give, if you give 101, finally it has to end in 1. If I give 25, it has to end in 1 as well. I hope this makes sense. and the way it is done is there is a while loop which checks if the number is 1. If the number is 1, then it should end, but till it is not equal to 1, the given number is divided by 2 or multiplied by 3 plus 1. Based on the number is an even or an odd number, these two operations are performed, and then the same number is checked if it is equal to 1. If the number becomes 1, then we come out of the while loop. But until the number becomes 1, we use this if and else. If it is an even number, we just divide by 2. If it is an odd number, we multiply by 3 and add 1. So we use this floor division because we don't want a floating point number, we only want an integer, and that's the reason why we use a floor division. So this is a beautiful way to check the Collat's conjecture from any given number. So I hope you make sense of the logic that is given in the program. So whatever number you give is an input. It uses this if loop and else loop based on the fact that the number is an even number or an odd number. Finally, the answer comes to 1 and the loop ends. And at the end of it, we have this Collat's conjecture as a series. Okay, so one of the other important questions that get asked is to remove the outliers from the given numbers. So as you can see, so this is the main program which actually takes the input, right? So you give considerable, for example, let me give 1, 2, 3, 4, 5. So I have these 5 numbers, and you can see the outliers are 1 and 5. The rest of the numbers are printed as such. So here the way we remove the outliers is we just remove the first value and the last value by using these remove outliers. So there are many ways of removing the outliers. So here we are using a very simple way. We are thinking we are assuming that once you sort the data, so which is important actually, to remove the outliers you need to sort the data. Once you sort the data, which you do here, you just remove the last element in the series and the first element in the series, and then because you have removed the last element and the first element, it automatically has removed the outliers. So this is a very simple way of removing the outliers. There are little more complicated methods of to arrive at the outliers, but I have just shown a very simple way of removing the first element and the last element, right? So here this while loop is used to take the numbers, and then if you don't enter any number and just press enter, it will come out of the while loop. Let's enter a different set of numbers. Let's enter 45, 78, 99, 107, 87, 839. So we have entered 6 numbers. Let's enter 3 more. So we have entered 9 numbers. Let's complete the entry. So we have entered these 9 numbers. As you can see, the outliers which are 869 and 23, they are removed, and then the rest of the numbers are presented as such. So this is a very simple way of removing the outliers. So outliers generally it doesn't affect the mode, but it affects the outlier. It affects the average of the system. So some of the applications demand that outliers be removed, and this is a way of removing that. So this is a function. This def remove outliers is a function, and from the main program I call this function, and this particular set of the code is used to take inputs. So as the input is entered, I append the input values to the values variable. Values variable is a list. So I append it to the list, and then if the value that is entered is a blank line, which is I press enter without any number, it will quit the loop. At the end of it, after the values list is formed, it is passed to the remove outliers function over here, right? It is passed and the remove outliers, the number of outliers is removed, right? So this is so here I just pass the value 1, which is passed over here. It is the number of outliers which you want to remove on either side of the data. So suppose I am saying that I have these 9 values. So I want to remove one outlier to the right and one outlier to the left, right? That is the number of outliers I want to remove. In case I pass this as 2, right? So let me enter the data once again. 34. So I enter a set of values. So you can see that I have entered 9 values. So you can see here, out of this 9, it has removed 2 outliers to the left and 2 outliers to the right. So, and what is remaining are only 5 values. So after sorting, it has removed 2 outliers to the right and 2 outliers to the left. So this is an interesting way to remove the outliers from the given set of numbers, and this is a very popular question for beginners as well as for people who enter into data science to check their knowledge of Python basics and their ability to understand the logic and code. Yeah, this is a very interesting beginners program as well, but slightly interesting. If you enter the name of the month, it's going to give you the number of days. For example, let me enter September. So it says 30 days in it. Let me enter February, 28 or 29 days in it, depending on the fact that it's a leap year or a normal year. So the way it is done is, we assume that many of the months have number of days as 31. Most of the months have 31 days. Only 4 months, which is April, June, September and November, have 30 days. And February has 29 or 28 days, depending on the fact that it's a leap year or not, right? The rest of the 7 months in a year have 31 days. So I have taken 31 as the default value here, because maximum number of months have 31 days. 4 months have 30 days. So if the month is April, June, September or November, then the number of days is 30. If it's February, it is 28 or 29, right? So I have this if else, where if the month is one of these 4, then it's 30. If the month is February, then it's 29 or 28, depending on the fact that it's a leap year or not. So I am entering now January, so which has 31 days in it. So you can clearly see that the number of days is 31 for this, and this is an interesting way to calculate or to find the if you give the month, it will give you the number of days. It's a very simple program, but it's and the logic is also very clearly written. So this is a much easier program, so which you should do at the beginning. So if you want to give the number of factors of a given number, so if you want, for example, let's say I give 6, so it will give you all the numbers that are divisible by 6. So even when you start from 1, let me give a 6, and it's giving you that from the number 6 till 96 we have all these numbers which are divisible by 6. Similarly, you can also consider that you can also write this program which starts from 7, and then if you give a number 7, so here we don't divide the number, but it's just that we skip 7 numbers after printing the first 7. So 7 is printed first, and then we take the input and then skip that many numbers. to print the successive numbers. So we print 7 and then skip 7 numbers to print 14, skip another 7 to print 21, and so on. If you want to print the factors of 8, we can give 0 as well, but here I give let's say factors of 9. So it's going to give me all the numbers that are divided by 9. Of course 0 doesn't divide by 9, but the quotient is 0 as well, right? So this is another way which uses list comprehension. So let's say I'm giving a number 9 and it's giving me all the numbers that are divided by 9, starting from 9 up to 101. So you can see all the numbers from 9, 18, 27, 36 up to this 99, which are divided by 9. So this is a list comprehension where, so you can even read this as x, set of all x such that x is in the range of 1 to 101, and x divided by the number is equal to 0. That is, x mod of the number is equal to 0, which means print all x which are in the range 1 to 101 if the x value divides exactly by the given number. So this is the list comprehension way of doing it. This is the normal way of doing that, which is using a for loop and a if loop. This is using the idea of range, and this is using the idea of list comprehension to print all the numbers. This is again using the range as well, but this uses the list comprehension, and the number, instead of taking the number separately outside, the number is taken inside. So these are three different ways of printing the factors of a given number. So the first way is using a for loop and a if loop. The second way is to use a for loop with the range, and the third way, or using a list comprehension and then taking a number and then generating the numbers which are divided by the given number. So here we go. So this is another interesting program which stores all the, so let's say the size of the list is 3. So enter the elements of the list, 9. You can see that I have 4, 7, 9. All the subsets of the 4, 7, 9 are printed. So there is an empty set, 4, 7, 4, 7, 9, 7, 7, 9, and 9. So you can see all the subsets of the given number 4, 7, 9 are printed, and the way we do it is by using a twin for loop, and then we append based on a I colon j. So I is the count variable in the upper for loop, and j is the variable in the lower for loop. We use the idea of a I colon j, and then appending b is the list that we are going to generate, and then appending this sub to each of the b values, we get this all the subsets of the given list. So if you give 4 numbers, so let's say I'm going to give 5 numbers. So you can see all the subsets of the given number are printed, right? And you might be wondering, what is the number of elements in this subset? So this will be, if there are 5 elements in the main set, the number of elements in the subset will be 2 to the power of 5 minus 1. So here you will have 31 elements inside, right? Here you will have 31 elements inside. So if I give only 3 numbers, which is 4, 5, and 6, so I will have 8 sets in the subset. You can count this: 2, 3, 4, 5, 6, 7. So 7 subsets in the main set, which is 2 to the power 3, which is 8 minus 1. Right, this is an interesting way to print all the subsets of the given list. So this is also a program that people often face in the interviews, as well as you should try to understand and do it yourself when you are understanding Python. The most famous of all the programs, there are a couple of programs which are most famous. One is the prime number program, and the other is the perfect number program. So you can see that the prime number program here generates numbers from 2 up to the given number. Let's say I want to generate prime numbers till 100. So you start from 2 and then you have an inner for loop where you produce this div which will be dividing the val. So val divided by div, if it is equal to 0, that means the number is a divisor, exact divisor. If it is exactly dividing, then this val will not be a prime number for sure. So flag is set to 1 and then you break from it, and then outside of this for loop you check if the flag was 0 still. If the flag was 0, then it prints that particular number, right? If the flag was 0, it is a prime number. The flag was 0, this number val was not a prime number. So it will print the if loop, it will print the number that is divided here, right? None of the numbers get divided, which means that val is a prime number. So val is printed. So you will start from 2, 3, 5, 7 and so on till 97. All of these are prime numbers. And one interesting thing in this program is if you want to print all the composite numbers, you just have to check if the flag is equal to 1. So this is going to print all the composite numbers which are not the prime numbers till 100. So this is the flag is very convenient here. If the flag is turned to opposite value, it will print the composite number. If the flag is 0, then it's going to print the prime numbers. So this is a very interesting way to print the prime numbers by using the twin for loop. Certainly you can reduce the time taken by only looking for numbers that are divisible till half of this number. So we can optimize these programs very well, or by using the square root of these numbers we can optimize these programs very well. So you can also have a way of removing this flag. So if you use else, which is kind of a floating else, so you will be able to remove the flag, and this else part will be executed if the if statement was never executed inside the inner for loop. Yeah, which is very important. I'll repeat. If the if statement never got executed in the inner for loop, then this else will be executed. So we have a list here. We append all the numbers to the prime list, and then we return this prime list here, which is then printed. So at one shot it will be printing everything which is in the prime list. So as you can see, the new list is a list variable, and whatever is returned here, which is the prime list, comes and sits in this new list, and then the new list is printed as a list. So this is a very good way of printing the prime numbers by using a list and appending all the numbers to the list. The other very popular program that newcomers face all the time, or if you are learning a language, the one thing that you want to do to understand the idea of for loops and while loops is to do the perfect number program, both with a for loop and a while loop, using a function as well. So here you can see that I go through the numbers from 2 to 10,000. There is an inner for loop that divides each of the numbers here by the number which is generated in the inner for loop, and then a sum value is kept. So for each of the number that we are selecting in the outer for loop, the sum value is reset to 0, and then if the sum is equal to the val, then we say that it's a perfect number. See, some of the examples of perfect numbers are one of the numbers is 6. So the factors of 6 are 1, 2, 3. So if you add 1 plus 2 plus 3, you get 6. The other number is 28. So if you look at the factors of 28, which is 1, 2, 4, 7, 14. So if you add 1 plus 2, 3, 7, 7 plus 7, 14, 14 plus 14, 28. So you get 28, which is the number itself. So 28 is a number. So we have only 4 numbers still around 1 million as well. So we have 6, 28, 496 and 8128. So you can see there are only 4 numbers till around a million. So here we are only checking for 10,000, but even if you had checked for a million, you would have got 4 numbers. So this is very interesting that there are only four numbers till a very long range as well, which are perfect numbers. And the way of doing that is this outer for loop generates the numbers which are going to be tested, and the sum is reset to 0 for every generation of the number in the outer for loop. In the inner for loop, you have the div, and then this div is generated from 1 till the number that you are using here. So we have the div that goes from 1. So let's say the outer for loop is generating 50. The inner for loop will generate numbers from 1 to 49. So and then that is divided. So 50 divided by 1, 50 divided by 2, and so on. And if there is a factor, then that factor is added to the sum. And if the sum is equal to the original number that was generated in this outer for loop, then we have a perfect number. Now the same perfect number concept here is written as a function. You see, this is a perfect number function. So this perfect number function does the same thing, use 2 for loops. The outer for loop generates the actual number which is going to be tested for the perfect number. The inner for loop generates again the numbers. So you can see that we generate the perfect numbers and put it in a perfect list. So this is the list, and then as the sum is equal to the val that was generated in the outer for loop, and this would mean that we have a perfect number, and that is appended to the list. Finally, the complete perfect number list is returned to the new list variable here. So we call the perfect number function, and then it is returned as a new list, and it is stored over here, right? So finally, the new list, which is containing the list of perfect number, is stored. So here 1 by 1 is not printed because we are calling this function. The function generates and at once all the 4 numbers are returned in a list. So only after a couple of seconds, only after 5 or 10 seconds, you will see all the numbers coming at one shot. See here, the numbers will come one by one. You can see one by one. The reason is it is not appending it to a list and returning, right? But here we are actually appending to a list, and at one shot it is getting returned and printed. That's the reason it prints all the numbers at one shot together, right? So this is also a very interesting program that is asked for the beginners who go for interviews. And also this is something that all language learners, especially Python, need to work by themselves. So actually what you can do is you can look at this program and the explanation that I'm giving here, and then you can do this program yourself without looking at it. You can type the program and see that running. So therefore you can get practice in the for loop and the usage of the different values and the minute nuances, like why I am starting from 2 here, why I am starting from 1 here, and all those things you will come to understand. So here is a very interesting program. All of you must have done it at some part of your life, but it's a very interesting program, not only because it's getting asked for people who just come out of colleges and after graduation. It's also an important program to understand how recursion works. So this, suppose we give a number 5, so it's going to give me 120. So we give a number 5, again it's going to give me 120. So this uses iterative concept, which is using a for loop. This uses a for loop to take the number, and then you go through the for loop and you keep multiplying that, and finally when the number is reached, you come out of the for loop and print the result. So here we go. So we give a 6 and the answer should be 720. So we give a 4, the answer should be 24. So this one uses the idea of recursion. So this is the main recursive call. So this is also sometimes called as tail recursion because of the fact that last line is a is a recursive call. But other than that, if the number is 1, then we return 1. If it's not a 1, then we call the same factorial function with one number less. Suppose if the number is 5, for example, the if loop will not be executed, so it will come to the else part. 5 multiplied by factorial of 4, so it will come back here again, it will be 4, so 4 multiplied by factorial of 3, and so on. So finally you will see that if you are giving a number 5, what we are actually doing is 5 into 4 into 3 into 2 into 1 is what we are doing. So this program is through iteration and this program is through recursion. So this is finding the factorial of the given number with the iterative method and with the recursive method. Now let's see the question to print the Fibonacci series using recursion and without using recursion. Let's see how Python takes this. Let's first give how many numbers of Fibonacci series we want. If we give 10 numbers, we're going to get 10 numbers of Fibonacci series. So you can see that it accepts the number of Fibonacci numbers that you want. The first two numbers 0 and 1 already get printed, and then from the third number onwards till the number that you want to print, so we have a for loop which iteratively prints the next number, which is the sum of the previous two numbers. So Fibonacci series is nothing but the next number is the sum of the previous two numbers. So we store the numbers as first and second, and then the first and second move on as we move forward. So this is just an iterative method to print the Fibonacci series, and it will go till val plus 1 because for the range it completes 1 before the number that is provided here. So which is why we go till val plus 1. The first two numbers are already printed here, which is 0 and 1, and that is why we start from 3. So I hope that makes it clear. And then the sum is the sum of the first and the second. As the sum is printed, for the next iteration the first becomes the second and the second becomes the sum. You know, if you say that 2 plus 3 is equal to 5, in order to get 5 you have to add the previous two numbers. For the next iteration the first becomes 3 and the second becomes 5, and then it comes inside 3 plus 5 is equal to 8, and then for the next iteration first becomes 5 and second becomes 8. So which is what we are doing here in a single line. First becomes second and the second becomes sum. So the window of first and second moves on as you calculate successive Fibonacci number. So this is a very simple way of calculating the Fibonacci numbers iteratively. Now the same thing can be little more logically and little more clearly done using recursion. So here the idea of Fibonacci series is the sum of the previous number and the number before that. So if the number is 0 or 1, you return the same number. You know, as you can see, the first number will already be 0, and then the second number will be a 1, and the third number will be a 1. So if the number you want to find is 0 or 1, you return the same number. Otherwise you calculate the Fibonacci of the previous number and the Fibonacci of the number before that. So we recursively calculate till the last number, and then we add the successive numbers to get the Fibonacci series. So this is a Fibonacci series generator which uses recursion. So here we actually print the Fibonacci numbers, 17 Fibonacci numbers we print. So as you can see, the same thing is printed here, right? So this uses the idea of Fibonacci series is the sum of the previous number and the number before that. But how do you get the previous number? It is nothing but the Fibonacci series of the previous number and then the Fibonacci series of the number before that, which is very logical. So you can see this is much more clear, but in terms of working, we have to really get into this to find out how it works. But the idea and the code is a little more clearer in the recursive version of the Fibonacci series than here. So it depends on the perspective though. Right, so we saw for the factorial how to generate the factorial in an iterative manner and how to generate the factorial using recursion. Similarly, we saw how to generate a Fibonacci series in an iterative manner and how to generate a Fibonacci series using recursion. Yeah, so let's look at one of the most famous problems in every language as you go into the interviews, which is the generation of Armstrong numbers in the given range. So you can see here we have generated the Armstrong numbers. So you can see that, let's clear the cell to show you one more time. So what are the Armstrong numbers till around 2000? So you can see that 1 is an Armstrong number and 153 is an Armstrong number as well. The reason is if you take the cube of 1, which is 1, cube of 5 is 125, so total is 126, and cube of 3 is 27, so 126 plus 27 is 153 as well. Similarly, the cube of 3 is you can say cube of 3 is 27, and then the cube of 7, 7 into 7 into 7 is 343 plus 27 is 370. And similarly, 371 is also an Armstrong number because 370 plus 1 is 371. The cube of 3 is 27. 27 plus cube of 7 is 343, which is 370. 370 plus cube of 1 is 1. So adding all the 3, we get 371. And similarly, we'll see that 407 is an Armstrong number, which is 343 plus cube of 4, which is 64. 343 plus 64 is a 407. Cube of 0 is 0, so nothing adds to it. So these are some of the Armstrong numbers till 2000. So how do you generate that? Very easy, because every number is a string, and therefore you consider every number here. For every character, this is a number that you generate in the range 1 to 2000, so you convert it as a string. If you have a string, then you can take each number as a character, and then you convert it back to an integer, and then you take the cube of that, because when you want to find the cube, you will have to convert it into an integer. But here we are going through iteratively in a for loop, so we need a string for that, because we cannot iteratively go through using a number. So we conveniently use these typecastings to our advantage. So, and then the sum is equal to sum plus cube. So here you can see that the cube and the sum are reset after every outer loop number. So this is obvious, because when you calculate the sum of the cubes, you need the sum to be reset after every loop number in the outer loop, every number in the outer loop. So only then the sum will come correctly. And finally, if the sum of the cubes of the individual numbers is equal to the given number, then that is an Armstrong number. So which is what we are doing it. So here the same Armstrong number is calculated using a function, and then the list of Armstrong numbers is returned back to the user, and then it is actually printed in the new list. So the same program, but we have used a function, and then we have created a arm list, which is an empty list, and then as you find the Armstrong numbers using these double for loop, so we just append the Armstrong number to the empty list over here and then return the empty list. but the logic for both the programs, as you can see, the for loop and the sum logic is the same. So this part of the program is the same as this part of the program. Only thing is, in this case we directly print the Armstrong number, but whereas here we append it to the empty list, which is the Armstrong number list. So the same program, for the sake of people who want to do this in a function, so you have you're seeing a function here, and then there is an empty list of numbers, and once you run this empty list is appended with the Armstrong numbers as you go through the number till 2000, and then it is returned, it is captured in the new list and then printed. So you can see these 5 numbers, 153, 370, 371 and 407 are Armstrong numbers. The other one which we very often talk about is to remove the duplicate numbers from the given set of numbers. So if you give a particular set of numbers, for example, if you say I want to give these numbers, where you can see that the number gets repeated. Let's repeat the numbers, and then 45 gets repeated as well. So we have these 9 numbers. You can see that 77 gets repeated, 45 gets repeated, and 56 gets repeated as well. So there are 3 45s, which means out of these 9 numbers, 5 numbers are duplicates, because 2 45s are duplicates, 77 is duplicate, so third number is gone, 56 is a duplicate, fourth number is gone, and 45 there are two duplicates. So we have 5 numbers which are duplicates, so which are removed out of this. So how does this work? So when you give these sequence of numbers, this is taken as an input, and then we strip each of the numbers out. We actually strip the trailing and the leading blanks in the sequence. See, for example, I have not given any blanks in front or after that. Suppose if I do give, suppose I give 3 4, I give some leading blanks, and then I give these numbers and then some blanks here as well. So if I do that, this strip function will remove all the leading and the trailing blanks and then give it only the numbers. But it will, how will it remove the numbers separately? It will use this split statement where the default is a space. So if you want to split on some other character, you can give it here, but the default is an empty space. So we didn't give anything for the split to split the numbers, so the default is taken as an empty space. So all these inputs are given, it comes out of the strip and the split function, and each of these numbers, which are individually strings, when it comes out of the input statement and going through strip and split, you get an individual string. 45 is a string, 56 is a string, and so on. Now the map function maps the integer function onto each of these numbers and then converts each number, which is a string right now, into an integer. So it converts each one into an integer, and then we pass it on to the set. So this is passed on to the set, where the set actually removes the duplicates. So basically, if you form a set with a list of numbers, it will actually remove the duplicates and give the output to you. Right now we are giving the input as a sequence, and which is a list that we get. So once we pass through the set, it gets converted into a set of numbers. So we don't want a set of numbers to be sent as output, so we convert it into a list back again and then print it. So the reason is we want the output to be in the form of a list, because we gave the output of the input is a list of string of numbers, so we want a list of integer numbers as well, so we convert it into a list. So overall the input function takes the whole thing as an input, as a sequence of numbers. The strip removes the trailing and the leading blanks, if at all any, and the split, which will take out each number, and the splitting criteria is an empty space. And then we have this map function, which maps the integer function onto each of these numbers, which is a string, and then it converts it into an integer. So once it is converted into an integer, these integer numbers, all of these integer numbers are passed to the set. So set removes the duplicates, and then the output of that is passed on to the list function, which actually gives out the output in the form of a list of integer numbers. So you can see that this single line removes the duplicate numbers from the given sequence of numbers. So these are the 20 programs which are most often tested even for some senior Python professionals. And if you are learning Python, you need to understand these 20 questions, so that you can write code on your own for these questions, and then you get a hang of writing Python programs as well. So hope you liked it. Thanks for watching. Do subscribe and give your comments, or if you have an idea of any other video that I should do in the coming days and weeks, please do suggest. Thanks a lot.